tell you the most important things you need to know about carbon management. Why are we talking about carbon management? Well, I would say 20 years ago, we weren't talking about it as much. It was much more a focus just on mitigation and reducing carbon emissions. But we are to a point now where we're seeing that the ability for our planet to be at 1.5 degrees or 2 degrees above the pre-industrial level, which are levels that scientists tell us we need to be at in order to have a livable planet for humanity without some of the most extreme impacts of climate change. We really have to be talking about carbon management and ways to reduce our carbon loading on the atmosphere. So I'm going to talk about these different buckets. What do they mean? What do we mean by carbon management? Here I'm just showing you, how our emissions profile looks like, what predictions have said in the future, and what temperatures those would lead to in terms of different scenarios of what does our carbon emissions look like in the future. And I would say to get below 1.5 or down here at 2 degrees, we really are going to have to think about going negative with our carbon emissions. So that's not just stopping releasing carbon dioxide into the atmosphere, but actually removing carbon dioxide we have released into the atmosphere in order to keep our planet down at these livable levels. There are a lot of sectors in our economy that are really more challenging to decarbonize. So carbon management is also sometimes looked at as a solution for some of those sectors that are harder to find decarbonized solutions. So for example, when we're producing electricity, we can use wind or solar or nuclear. These are all decarbonized options. They still give us electricity that we can use in our economy. Things like production of iron and steel or cement process that automatically reduces CO2, there are harder to find those technological options to decarbonize those sectors, especially if we're looking at things that are cost effective. And so carbon management will be part of the solution to decarbonizing our system and kind of offsetting some of those hard to decarbonize sectors as we figure out the technological solutions to no longer emit carbon from those sectors. So what does it mean? We put together this drawing to kind of give you a sense of what we're talking about with carbon management. There are different terms that are really important for you you've probably heard about or they're used in the media. So CDR refers to carbon dioxide removal. The key here when we're talking about carbon dioxide removal, we're talking about removal from the atmosphere. So it is actually CO2 that is in the atmosphere that we're trying to remove it either through natural methods or technological methods, but it is removal of that carbon dioxide from the atmosphere. Carbon capture refers to industrial processes or other things that we're capturing that carbon. And so when we're talking about carbon capture, sometimes they're talking about the direct air capture that's kind of in between, but usually we're talking about capturing it from industrial sites directly rather than capturing it from the atmosphere. Now we've captured the CO2. Now, what do we do with it? Sometimes, and especially in some of these nature-based solutions, the capturing and the sequestering or the putting it away or the storage of that carbon are kind of all in the same process. Other times, especially if we're doing these industrial processes, now we have the CO2 captured. We can either utilize it, we can make it into products, or we can do long-term storage. A lot of times people talk about underground storage, but there's a lot of different storage options. One key concept in thinking about the efficiency and our ability to capture that carbon is how much energy it takes to do that separation. So when we are capturing carbon, we have to separate it from everything else. So if in the air, we just want the carbon, we don't want the oxygen molecules or the nitrogen, the NO2 molecules or things like that, nitrogen molecules. You don't want those things. You have to separate that carbon. This is true in industrial processes too. You want to remove everything else. So whether that's sulfur dioxide or CO or other things, you want to remove it and just have your carbon dioxide. The higher the concentration of the CO2 in that stream, the easier it is to separate. And so when we're looking at the concentration of CO2 for different streams or compared to the air, you can get a sense of how much energy it takes to do that separation process and therefore the cost of doing that separation process. So a lot of industrial processes, these seem a little more ideal for carbon capture because the concentration of CO2 in those streams is much higher. When we get to something like air, even though we have concerns about our CO2 in the air because it is having this impact as a greenhouse gas, it's a long-lived pollutant, it's in our atmosphere for 100 years, it is still a very low concentration compared to all the other things that are in our air. This is especially important when you're thinking about engineered solutions. Natural solutions, our plants, our ocean, those automatically already take things out of the air. We take CO2 out of the air with plants, that's how they grow. And so just thinking of ways to boost those systems are another way we can think about removing CO2 from the air. So there's a wide range of nature-based and technological carbon dioxide removal projects. Remember, that's removing carbon dioxide from the air. This is just a nice picture that NOAA put together, looking at all the different ways that we can use our ocean, we can use biomass, we can use direct air capture, reforestation, afforestation. There's a lot of different ways to remove carbon dioxide from the air. And so there are companies, startups, others that are really looking at amplifying carbon dioxide removal through a lot of these different approaches. So the status of CDR right now, we have, over 400 suppliers across the globe, about 150 that are focused on the markets part of this system. And you can see a lot of the focus is on these nature-based systems because those nature-based systems are really just amplifying our natural processes. DAC, this is direct air capture. This is the engineered portion. So you can see it's a little over a quarter of the type of carbon dioxide removal systems that is being invested in are in these direct air capture projects. So direct air capture, maybe you've heard about this on the news. Think about big fans. There's basically a solvent process where a solvent will absorb the CO2 from the atmosphere, and then you can heat up that solvent to re-release the CO2, and then you need to do something with the CO2, whether that's utilize it or store it. A lot of times these systems are very energy intensive, but they can be sited anywhere. And so much of the effort has been to site them where there is a good site for a lot of energy production. So for example, geothermal facilities where you could have geothermal producing a lot of the energy directly coupled to a direct air capture facility that's using that energy. And it can be remote, it can be away from infrastructure. Okay, so that's direct air capture. Carbon capture and storage, which you've also probably heard about. This is more the technological. Often it is talking about removing, capturing that carbon directly from emissions. Then you're transporting it, and the storage part is often geologic storage. So the status of carbon capture, there's about 50 operating projects, a lot that are in development or construction, but we have to see how many of those actually are producing the carbon capture and storage. So you can see we're kind of at 50 megatons of CO2 carbon capture and storage today. And I'll give you a sense later on how much the International Energy Agency really thinks we need to get to in order to get to those net negative emissions we need to keep our carbon budget under 2 degrees. Okay, so you've captured the carbon, whether it's from the atmosphere or from our technological or our emissions, something like that. A lot of times the next step is transportation because sometimes where you're capturing the carbon isn't where you're going to store it or utilize it. Sometimes it's co-located and sometimes not. So we're pretty early stages in having any sort of CO2 transportation network, but there are efforts to look at expanding CO2 networks in terms of pipeline construction or other ways of transporting our CO2. Okay, now we've got the CO2. Now what are we going to do with it? There are companies that are looking at using it. We call that carbon utilization. So we can use the CO2, we can run it through some processes to make fuels, so you can make it back into the fuels that it was originally. You can make plastics out of it. You can do other things to utilize it. Recognizing that some of the key distinctions with utilization, if you make it into a fuel, so back into like a diesel or gasoline fuel, you're going to be burning that in order to use it as energy. So you're going to be re-releasing that CO2 back to the atmosphere. Whereas if you're putting it into something like a plastic, that's a longer term storage option. So the utilization of these, it does differ on how much carbon is actually being removed from the atmosphere. And then you can do storage. And often when we talk about storage, we're talking about geologic storage. CO2 can be stored underground in aquifers, so deep aquifers. It can be stored underground in old natural gas or oil reservoirs. You're talking about sedimentary basins that have Porosity and permeability, that's where we're getting our oil and gas out of the rocks. We can put CO2 back in and have long-term storage there. You do have to worry about leakage. We want this to be long-term storage. So the monitoring of these systems is really important. You can put it in places where the CO2 actually becomes heavier than things like water, depending on how deep in the ground you're putting it. That can really help keep that long-term storage of CO2. We do have sedimentary basins all around the world, some of them that have or did have oil and gas in those reservoirs, some of them that still have it in the oil and gas reservoirs, some of them that didn't, they had water or other things in those sedimentary basins. So there's a lot of like globally storage sites that are potential for carbon capture and storage, but not a lot of them are being used today. So our carbon management today is really small, and it's much smaller than even the small part of the solution that the IEA says carbon management needs to be. So really key to think about is carbon management, carbon capture and storage, CDR, are not going to allow us to just keep using fossil fuels. We have to both stop using fossil fuels and have carbon management in order to keep the planet below 2 degrees Celsius. So what we're doing today is a far cry from what the IEA says we need to do for some of its net zero scenarios. An important piece of this is that most places it is still free to emit carbon to the atmosphere. And so if we're not internalizing that externality, it becomes really hard to drive investment and scale some of these technologies to actually reduce carbon emissions. There's kind of two ways that's often talked about to put a price on carbon to try to internalize that externality of climate change. Cap and trade is one. It's a pretty popular one that's used in different jurisdictions around the world. A carbon tax is another one where you're just basically adding a price directly to carbon emissions. But those carbon pricing instruments are not widespread today. There are areas, Europe, California, some other places like in the northeast of the United States, China, they do have some carbon pricing instruments, but they're not widespread. And the price on carbon is often lower than what scientists say is the true social cost of carbon. So it is hard, it's hard to drive investment towards some of these carbon management technologies. But that doesn't mean it's not happening. And some of the most excitement in especially the venture area on carbon management is something called advanced market commitments, where companies are actually choosing to put a price on carbon by buying durable carbon dioxide reduction. So companies are being motivated either by trying to get ahead of the curve and they're seeing a price on carbon coming, or by being able to market themselves as having zero carbon, and that can be a benefit in the market. So they are actually putting money into these advanced market commitments. Okay, so that's kind of the landscape of carbon management. If you want to know more, we have two experts on our website talking about it. And of course, join our Energy Spotlight.